Welcome back, Algebra 3. We are in Lesson 31. We're going to talk about symmetry first. So symmetry is another way to say sameness. So here are some illustrations that you probably want to put into your notes just so you can remember how it relates. So when I say symmetry about the x-axis, that means that the x-axis is going to be kind of like your fold line. That is where it is relative to. So we have a line here that is symmetrical about the x-axis, and that means that at this point on the x-axis, it is the same vertically up as it is down. So it's 2 units up and it's 2 units down. So it is symmetrical about the x-axis because the x-axis is kind of like its fold line, right? Here I have symmetry about the y-axis. I have a little shape here, and it connects at 2 points. It goes up 1, down 1, over 1. And if you look across, you see a symmetrical shape, the same one, out 1, down 1, over 1. So it is the same shape on both sides, and it is centered on the y-axis. Okay, now when we have that, we call that line that they are symmetrical about, we call that the axis of symmetry. And when it is the x-axis, it's symmetrical about the x-axis. When it is the y-axis, it's symmetrical about the y-axis, meaning you could take it and fold it on the y or the x, and they would be duplicates of each other, right? The same. But it doesn't have to be on the y or the x for it to have an axis of symmetry. The axis of symmetry is simply the line at which you could fold the shape and it would be identical on this side and identical on this side. Sometimes that's the x-axis, sometimes it's the y-axis, and sometimes it's not. Sometimes it's out here on another point or another location. But that would be what we consider to be the axis of symmetry. Then you have something where you have multiple axes of symmetry. And that is usually going to be in a more of a circle or a box or a square, something that's symmetrical all the way around. So here we have symmetry about the origin. And all that means is our symmetry, our point of symmetry, is going to be on the origin. It's on the y and the x-axis, and that is our origin here. So a circle is a good one to illustrate symmetry about the origin, because when I draw a radius here, it's going to be the same as if I draw the radius here. And if I fold this on the origin, right, on this diameter that I've drawn, I have exactly a half circle here and exactly a half circle here if I fold it on this line right here. And that diameter would be my axis of symmetry. But then I could also fold it on the y-axis and I would get half and half. I could fold it on the x-axis and get half and half. I could create any diameter I wanted to because there's tons of radius or radii within a circle, and they are all exactly the same length. So any two that are 180 degrees away from each other that completely bisect the circle creates an axis of symmetry about the origin. Okay? All right, so you might want to put these in your notes so that you have an illustration of all the different types of symmetry that we have with these graphs. I am about to clear the page, so if you need to pause, do that now. So now we're going to talk about reflections. And yes, it is similar to symmetry, but it's a little bit different. So for instance, let's say I have, here is the x-axis, here's a y-axis, all right? And let's say on 1, 2, 3, let's put it on -4. Let's say I have a parabola on the -4. Let me bring that back down. Okay, so here's my parabola on the -4. And we remember a little bit about parabolas. We remember they have that little axis of symmetry going down through the middle, and they've got a vertex right here. We also know that for every point on a parabola on this side, we have it's the same distance away from the axis of symmetry on the other. So this is 1 unit from the axis. This is 1 unit from the axis of symmetry, right? This is 2 points or 2 units away from the axis of symmetry. This one is 2 points away from the axis of symmetry. So you see how that works, right? So a reflection of this, a reflection is not just at the line of symmetry or the axis of symmetry. A reflection is taking the whole function and flipping it over an axis on the Cartesian coordinate system. That is a reflection that we're talking about. So that would mean if I had a reflection of this parabola, then this is on the -4. I could flip it to the other side of the y-axis and go 1, 2, 3, 4, +4 on the x-axis, and I could create a duplicate. And again, I'm going to adjust it to make sure it's perfect, or as perfect as I can get it. All right, so again, this one is going to be 1 unit away from the axis of symmetry at the +1 on the y-axis, and up here at the +4 on the y-axis, they're both points on both sides are 2 units from the axis of symmetry. So that's pretty close to identical. But this one is a reflection of this one. This was the original, and we reflected it over here. So you can see the fold line is going to be, yes, these are, they have an axis of symmetry within the parabola where they are opposite. But we also have an axis of symmetry per se on the y-axis itself. We have a reflection of the y-axis along the x-axis here. So when we say a reflection on the y-axis, that means we fold it at the y-axis and mirror it over on the other side. Whatever's on the left or the right, we do it on the opposite. Sorry, that's my little thing to tell me it's getting close to bedtime. So the way we would write this as a function, let's say that this one, because it is a parabola, this is x squared plus 8x plus 16. The way we would notate that is to make every x a negative x. So y is equal to -x squared plus 8 times -x plus 16. Don't try to solve it. Just know that's how you note it. Trust me for now. So the rule for that would be that when we create a y-axis, I can't spell axis apparently, a y-axis reflection changes x to -x, okay? So what happens is our function notation goes from y is equal to f of x into y is equal to f of -x. See how that changes? It changes here. So when you want to write the reflection of this, you just change the x's to -x when it goes across the y-axis, okay? And the way we write that to show the rule is this. This is the rule. The x goes to a -x in the function notation. All right, what happens when we want to do it around, let's say up and down, around the x-axis or about the x-axis? So here's what would happen then. Let me do another one. So this is about the y-axis. Now we're going to do one about the x-axis. So here we have, I'm going to have to draw this kind of this way more. And here's my y-axis. All right, so now let's say I have that same function, 1, 2, 3, 4, and 1, 2, 3, 4. Okay. Put that right there. All right. So this function right here, this parabola, again, is the same as my other one. Right? My points are the same. But now I want to reflect it down across the x-axis or about the x-axis. This is, I still have the same line of symmetry that I had before, but now I'm going to reflect it about the x-axis, right? So what happens now is, actually I think what I'm going to do is move, no, I'm going to leave it. This is fine. This will be fine. So I have this, I want to reflect it upside down. So I'm going to have a point here and a point here, and then 1, 2, 3, 4. I'm going to have a point here and a point here. Okay. So let me draw that in. And that did not do what I wanted it to do. All right, let me adjust it, make it fit. Hopefully you can see where I'm going with this. All right, so now I have the same function, but it's upside down. One of the things that we notice is that it's going to share the same axis of symmetry. So that does not change. Here we have two different axes of symmetry. Here we have the same axis of symmetry because it just went up and down, right? So that remains the same. So that's one of the things that you can think about. And what's interesting now with our reflection, what changes is the y. So again, we have y is equal to x squared plus 8x plus 16. So when we have x-axis reflections, and this is actually, I'm sorry, this is this right here. When we have an x-axis reflection, we replace the y or I'm sorry, not replace, but it changes the y to negative y. So what happens is we get negative y is equal to x squared plus 8x plus 16. But look what happens. We don't like to have that negative on our y value here. We never like to see that negative value out there by itself. So we multiply both sides by negative 1, and we get y is equal to negative x squared plus 8x plus 16. So this is the format that we would write a reflection about the x-axis. So when it's about the y-axis, we change the x to negative x. When it's about the x-axis, we change a y to a negative y. That's what reflections are all about, okay? So it's a little mind-boggling that it is, if you think about it, it makes sense, right? This went from being a -4 to a +4. So x value got the opposite x value, right? So the same thing is kind of going on here. Here we have y values that now are the opposite y values. So think of it in those terms. Okay? All right, so that would be the new notation for that would be y is equal to f of x. That's the original notation of the function that we have here. But then when we reflect it about the y-axis, it changes to negative y is equal to f of x. But we don't like that, negative y, so we multiply both sides by negative 1, and y equals a negative f of x. Note where the negative signs are. That's what's important. You are going to have to pay close attention to that. That is the big deal, where the negative signs end up. Okay? So put that for sure, all in your notes. All right, so now let's talk a little bit about something called translation. I'm going to clear this, so if you need to pause and finish your notes, do so. So with translation is moving functions. Trans would be means to move or change or different. So a translation of a function is going to have some impact on the function, obviously. So let's say we are moving, here's our y-axis, and I'm going to do our x-axis. Okay. And this is going to be what's called a lateral translation, right? A lateral because it means lateral means side to side, and it could also be called a horizontal translation because the horizon, the horizontal, that is side to side. So it could be either a lateral translation or a horizontal translation. Both of those are correct terminology, and I may use either one of them interchangeably. So just a heads up. All right, so let's say we have a function here, and it is on the origin. And again, we're going to use parabolas because, well, why not? So here is the points, just like normal. And I'm going to try to draw it in just cool like that. Maybe not so cool like that. All right, close enough to cool like that. Okay, so that's it. We'll pretend. We'll just use our imagination. That's pretty close to what I had before. All right, so here is the function that we have, and we want to translate it, meaning we want to move it. All right, so the original function is y is equal to x squared plus 2. This is our, actually it's not, hang on. All right, now this function is y equals x squared plus 2 because it's at the plus 2 on the y-axis. So that's the plus 2, right? I want to move this function, let's say 8 spaces to the left. Now remember, this is the negative side, and this is the positive side of the x-axis. That's going to be important to remember. So I want to move this 1, 2, 3, 4, 5, 6, 7, 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. I want to put it over here for whatever reason. And here's my points. And then I do this up here. And this is my parabola, and I'll adjust it pretty close. All right. That's pretty close. We will pretend that it is an exact copy of this one. So how would I translate that? How would I move that mathematically? I would write this as y is equal to x plus 8 squared plus 2. Notice I moved to the negative side of the x-axis, right? But I used a plus sign. Okay? So when we move to the negative side of the x-axis, we add the number of units. So, yes, I know you're already thinking it. When we move to 1, 2, 3, 4, 5, 6, 7, 8 here. 1, 2, 3, 4, 5, 6, 7. Yeah, that's 8. And here I'm going to reproduce our little parabola. I think I'm getting a little better at that. Look at there, almost perfect. We'll pretend it's an exact copy. So when I move it to the right towards the positive side of the x-axis, guess what? Yes, it is going to be x minus 8 squared plus 2. So remember that when we move or translate a parabola or a function from the right to the left, we add the number of units. When we go from the left to the right, we subtract the number of units. And we do that with the x value. Okay? So what about if I want to move it vertically and have a vertical translation, meaning an up and down translation? Okay, so let me draw a, I'll just continue what we have here. How about that? I'll just stretch that on down. So let's say I have a parabola here. Let's put him right about here. And we won't get so technical with these guys. Okay. I'm just going to move him down. Ignore that little mark right there. All right, so here's my parabola here. And this guy is going to be, I'm going to erase this little bit. We'll just pretend he's separate. This little guy here is y is equal to x squared plus 2. We'll pretend he is on the positive 2 line. If I want to move him, and in order to do that, let me put, this will be the x-axis right here, right? If this is the, nope, wrong spot, Tracy. If this is the positive 2, right there, right? This is the same place this guy's in, so x squared plus 2, x squared plus 2, same function. But let's say I want to move this guy up, right? I want to move him ahead 2. So I move him up 2. Now remember, this is the positive side of the y-axis. This is the negative side of the y-axis. It is the same process, only this time we adjust the y. So when I move him up 2, that becomes y minus 2 is equal to x squared plus 2. But what happens is we want to continue to solve for positive y for our function. So we add 2 to both sides, and we end up with y is equal to x squared plus 4. Because we did that math, that little calculation there, that changed it because we always want to solve for a positive y. Now what if I move him down 2? So I move him down 2, I put him on the origin, and we'll pretend that this is a duplicate copy of this red parabola right here. So I moved him down, so guess what? Y plus 2 is equal to x squared plus 2. Well, because we want to have this all by itself solved for y, we subtract 2 from both sides, and we end up with y is equal to x squared. How about those apples? So you can see how moving it on a particular axis affects, the translation affects that axis. So if you move it along the x-axis, you adjust the x value. If you go to the negative side of the x, you are going to add to the x value. If you move towards the positive side of the x, you are going to subtract from the x value. Now on the y-axis, we do it the same way, only we adjust the y value. So if we live right here and we want to move it up to, we would subtract. We go towards the positive, we subtract from the y value, and then we readjust our formula to have y by itself. Going down towards the negative side of the y-axis, we add to the y value, and then we adjust to solve for y by itself. I know it's kind of crazy how that works. It's opposite of what you think it is. This is what we would call vertical translation. I'm sure I said that, but I did not write it down. And I want you to have that in your notes. Vertical translation. All right, so our properties are, for lateral translation or horizontal translation, when we move to the left, we add to the x value. When we move to the right, we subtract from the x value. And we don't adjust. Right? When we have a vertical translation and we move up, we subtract from the y value. If we move down, we add to the y value, but then we adjust to solve for y. Okay, so those are the things we do when we have translation. All right, so let's do a couple practice problems. I think we have 3. Yes, we have 3 little practice problems. So pause if you need to take all these down in your notes, because I'm clearing the page now. All right, so here we have, this is 31.1. I have got a graph here. Make sure it's long enough and wide enough. I think maybe I should bring this down 1. There we go. That looks pretty good. All right, so here is my function. My function is y is equal to the square root of x. And it starts here. It's a square root function, and it does this number right here, right? Okay. So now I have a reflection of this over here. And on this one, it starts at the same place, but then it goes this direction, kind of like that. So it arcs out in the other direction. So this being a reflection of this, remember what we do for reflections, we adjust the x to the negative x. So that means we would write this function notation as y is equal to the square root of negative x, right? All we did was we changed the x value to a negative x. That's all we can do. And the reason we did that is because the reflection was about the y-axis. So when it's about the y-axis, we adjust the x value. Let's try another one. So now we have 31.2. And again, I'm going to have a a square root. And this one is going to be y is equal to the square root of x. Same one we started with last time. This one right here. And he starts here and he kind of arcs this way, right? So now I have another reflection. And not only is it a reflection, but it's a translation also. So let's put that in here. So his starting point is now at the -3, and he's upside down from my other guy. So we have both a reflection about the y-axis and a translation backwards 3 spaces to the negative side, right? So the first thing we need to do is we need to address the change in the reflection. So here we changed the x value because it was about the y-axis. So now we're going to change the y value because it was about the x-axis. So this originally, the first thing we would do to note the reflection, we would go from y equals square root of x to negative y equals the square root of x, but we have to solve for the positive y value, so we would multiply both sides by -1 and get y is equal to negative square root of x. We're not done, okay? We still have a translation here. And the translation happened on the x-axis. So what we've got to do is we've got to account for that shift in location. So 1, 2, 3, that's to the left. So that means we're going to add. So adding the translation would be y is equal to negative x plus 3. Okay? Remember, when it goes for the negative side, we add to the x value when it's moving along the x-axis. So that we handled from here to here to here. This was about the reflection and then the adjustment, right? This was about the translation. All right, let's do one more. All right, so now let me clear this. 31.3. So here we have the equation y is equal to 1 over x. So that is a reciprocal, right? Well, hang on, let me back up. We start with y is equal to x, and we know what that looks like. All right, and that looks like this. All right, so that's y equals x. We got that. That's not a biggie. Okay, so now we want to do the reciprocal. Y is equal to 1 over x, right? So that is going to look like this. We're going to have the 1 and 1 here and the 1 and 1 here. And then we're going to have vertical asymptotes here and here, where it never actually touches the axis, except by accident because Miss Tracy made a whoopsie. All right, I can do that over. It kind of goes there, and that kind of goes there, right? So the y-axis is our axis of avoidance. We don't touch it. So the graph of the reciprocal function y over x is here, and the original function crosses the x-axis at x is equal to 0. So the graph of the reciprocal function has a vertical asymptote at x is equal to 0. So the graph of the reciprocal function goes to the points where the original function had y values of -1 and 1. To shift this graph 3 units to the left, we replace x with x plus 3. So instead of it being y equals 1 over x, we want to move this over 3 spaces. So let's draw our other little map here, our Cartesian coordinate system. We are shifting our x values 3 spaces to the left. And we want to shift the unit, we want to translate it 4 units down. So again, we've got 2 translations going on here. So we're going to shift it 3 spaces this way and then 4 spaces down. So the best way to do that is to visualize it, is to take this point and move it. So 3 spaces to the left, 1, 2, 3, and 4 spaces down. 1, 2, 3, 4. And that puts it at -4, -5. Okay, so our vertical asymptote is going to be -3 here. Now we do the same thing with this point. 1, 2, 3, 1, 2, 3, 4. So yes, our vertical asymptote is right here. So that means we will come right up against this axis and go this way, and come right up against this axis and go this way. And this one will come right up against here and go this way. Maybe not quite straight of a line, more of a curve like that. And then this will be more of a curve like that. All right, so there is our, let me change the color here. This is our axis of avoidance. That's where we're not going to be connecting or touching. But then we have another one here where they don't touch either. Those are our vertical asymptotes. So what we have to do is we have to not only translate vertically, but we have to translate down as well. So the first thing we do is we adjust the x-axis for moving it 3 spaces to the left, right? Remember that's negative, but we do the opposite. So this can be y is equal to 1 over x plus 3. All right, that's the, this one is going to be 3 units to the left, or that way, 3 units that way. All right, now we have to adjust for 4 down. Remember, when we go 4 down, we're adjusting on the y-axis. This is negative, so we're going to add. So we're going to adjust the y value. So it's going to be y plus 4 is equal to 1 over x plus 3. So now we know we have to adjust the y value. So that's going to be -4 on both sides. So this is now translated to y is equal to 1 over x plus 3 minus 4. Okay? Not super hard. It just takes a minute to kind of visualize what you're doing and remember that the addition and subtraction are opposite the direction on the number line that you're moving towards, or that you're moving in relationship to, I guess is a better word. If you have any questions about this, please let me know. I can always send you some resource videos. Again, I can't help you if you don't ask, because I don't know you need it. So please ask if this is still confusing to you, and I will see you in lesson 32.